Hello everyone, here is today's problem. Suppose x is in between 0 and pi over 2. You're asked to show that 2 sine x plus tangent x is greater than or equals to 3x. We can show this inequality using the method in calculus. Surprisingly, we can also make use of AMGM inequality for this question. So if you just look at purely calculus question, this is the standard way. We let fx to be 2 sine x plus tangent x minus 3x, and f prime x equals 2 cosine x plus secant squared minus 3. Now note that f0 equals 2 sine 0 plus tangent 0 minus 3 times 0, which is 0. f0 equals to 0. So the plan is, if f prime x is always greater than or equals to 0, then fx will be greater than or equals to f0, and in this case will be greater than or equals to 0, and therefore we have the inequality that we want to show. But it is not clear why 2 cosine x plus secant square x minus 3 is at least 0. So we have two different ways to do it. First, we will continue to find f double prime x, and this is negative 2 sine plus 2 secant x. Then this is secant x tangent x. Secant is 1 over cosine, so this is negative 2 sine x plus 2 sine over cosine power 3. And this is 2 sine x over cosine power 3, 1 minus cosine power 3. For x in between 0 and pi over 2, cosine is in between 0 and 1. Therefore, cosine power 3 also in between 0 and 1. And this means that f double prime x is positive or 0. So meaning that the function f is concave upward. We can check for a particular x. If x equals to pi over 4, then fx is over root 2 plus 1 minus 3 pi over 4. Direct calculation, this is positive. With all this information, f0 equals 0, f pi over 4 positive, and f double prime x is always greater than e 0 for all x in between 0 and pi over 2. This shows that the graph of fx will be concave upward and it is always positive. Hence, fx is always greater than or equals to 0. And therefore, 2 sine x plus tangent x is greater than or equals to 3x as we reach. So that is using purely calculus method to get the inequality. Next, using our plan that we have just now, if we are able to show that f prime x is always positive, then we are done. So in order to get that, we consider cosine x plus secant square. Now x is in between 0 and pi over 2, so each of these is a non-negative value, and therefore this is greater than or equals to 3. The product cosine, and secant square to the power of 1 over 3. This is solved by AMGM inequality, and this equals 3. So 2 cosine x plus secant square is greater than or equals to 3. And this means that f prime x is always greater than or equals to 0. Since f prime x is greater than or equals to 0, together with f0 equals to 0, then we get the inequality that we wish. So for this method, we make use of AMGM inequality somewhere in the middle. For another method, we try to start with AMGM inequality, and for t in between 0 and pi over 2, sine t plus cosine t plus secant square t, as shown just now, using AMGM inequality, this is greater than or equals to 3. So 2 cosine t plus secant square t greater than or equals to 3. Now, both sides of the equation are positive. Then we can integrate 2 cosine t plus secant square t dt from 0 to x and do the same The same thing here. Integrate 3 dt from 0 to x. As we expected, this is 2 sine t plus tangent t from 0 to x. And this is 3t from 0 to x. And do the calculation. It is 2 sine x plus tangent x greater than equals to 3x. And again, this is the inequality that we want to prove. So that's all for today's lesson. Hope you enjoyed it. I will see you again next time. Bye bye.